policy. OSPF adjacency policy is not the actual topic, but that is how we use it in today's world. The actual topic is NBMA types, NBMA network types. So, as I said, I need one hub, one internet cloud, and two spokes enough. Usually, the internet cloud is considered as a frame relay. I'm not going to do frame relay to you. Okay, why not frame relay? Let's do it quickly. But again, I'm telling you, don't focus much on frame relay that I'm going to do. It may not be comfortable for you to listen to a topic which is not known. If you are okay, you can do so. I'm not against it, but not necessary now. But if you can understand, you can enjoy that. Right, frame relay is actually a very costly switch. But for a very small testing environment, you may use a router as a frame relay switch. So I'm going to make R2 a frame relay switch. For the appearance, it can be a router also, but I'm just going to change the symbol also to a frame relay switch to keep it more, at least to an extent, a realistic approach, realistic appearance. Frame relay. Here it is. Frame relay switch icon. All right, so it's actually a router. Only you and me know the secret. You're not really using our actual frame relay switch. FW, SW. Right? Now, let me first of all configure this frame relay switch. Then we'll get into OSPF. Well, let's start the routers. Again, you need only serial interfaces for frame relay. But when you use the NBMA mode as a adjacency policy, it can be applied on any interface. Right. Yeah. I don't know, the recording was mute for a long time. I just resumed. Oh, sorry. What am I doing? 6/2. All right. So next is I got another interface serial 6/2. Frame relay encapsulation frame relay INTF type DC frame relay route 403 exit interfaces serial 6/1 403 6/304 and then frame relay route 401 interface serial 6/0. Sorry, the LC number is going to be 104. All right, so I'm expecting the map to appear. Show frame relay route. This is the mapping, but you can see none of them are active. There are 3 bidirectional tunnels. That's why you see 6 entries. 3 tunnel means 6 endpoints, right? Yeah, 6 endpoints. So 6 lines you can see, but none of them are inactive. The reason is R1, R3, R4 is not frame relay yet. R1, R3, R4 are now serial. I would like to show you that. It's point to point now. Show interface serial 6/1. You can see here it's a point to point network. Show IP interface 6 serial 6/1. Anyway, I need to bring it up first. Interface serial 6/1. No shit. You see, I've said no shut down. It is actually a point to point HDLC interface. Look at this. It's a point to point. Point to point will run HDLC by default in Cisco. Non-Cisco will run PPP. PPP is nothing but point to point protocol. That's the encapsulation type on serial interface. Now, we have to convert this into frame relay first. Interface serial 6/1. No shit. I already given encapsulation frame relay. Period. Boom. Okay, that's very important. Next is I need to give an IP address. No, 10.0.0.1. Okay. So this is the IP address that we have on this interface, and on this I'm going to put 3, and on this I'm going to put 4. All right, that's it. We need to assign these IP addresses. I'll go to R3. If you watch it carefully, you'll see some magic show today. Yeah, I'm going to connect a magic now. So watch carefully. Encapsulation frame relay IP address 10.0.0.3. All right, on R3 I finished this, and let me just in 1 or 2 minutes maximum I will show you magic. So watch carefully. No shit. Encapsulation frame relay 4. Okay, now what is the magic? What is the magic? Before I perform that magic, I want to make sure everything is perfectly ready for the magic. I want to check whether my platform is okay to perform the magic. All right, I can see the magic can be performed because all are active now. Earlier it was inactive. All right, the table is ready. The magic comes here. I'm in router 4. There is no OSPF running, you know very well. Show frame relay map. This is the magic. This is the magic. I did not say anything about the other two routers to this router 3 and 4. But router 3 and 4 says, I already know these two guys. All that I need to do is I need to use this DLC numbers. 401, if I go to this tunnel, okay, let me router 4 says if I go to this tunnel endpoint, I can go to 10.0.0.1. Is that true? Yes. And if I go to this tunnel end, I can go to 10.0.0.3. Is it not a magic? Of course, it's a magic. In R3 and R4, you have not spoken anything about these numbers, user-defined numbers. These are all I gave. It was not any standard or something. I configured those numbers here on this middle box. And these IP addresses were configured somewhere remote routers. You have learned it here. Okay. Is it a magic? There is no magic. There is a protocol called inverse ARP. The purpose of this protocol is to resolve the DLC number and the IP address dynamically. We did not do anything for this. Not only in R4, in R1. Show frame relay. You can see router 1 says I can reach this address via these DLC numbers. It says R1 says if I take this 103, I can go to 10.0.0.3. If I take 104, I can go to 10.0.0.4. Okay, so that's all about frame relay now. Let us not focus on frame relay anymore. It's not bad to learn, but why? When it is not necessary immediate. There's no immediate necessary for frame relay in the industry. Old concept. May come back again, but let's enable OSPF. As of now, show IP route, show IP OSPF interface brief, nothing. Show IP protocol, nothing. Let me enable OSPF on interface serial 6/1. IP OSPF 1 area. Before that, for testing, I would like to have some interface loopbacks. Did I put loopback interface? No. Interface loopback. So that routes will be advertised and we can ping testing using the ping. IP OSPF 1 area 0. Interface serial 6/1 IP OSPF 1 area 0. OSPF is running on this interface. Show IP OSPF brief. But if you see the 6/1 show IP OSPF interface serial 6/1, you can see that the timers are 30 and 120. Hello packets are sent every 10 seconds, no? But remember last class we learned that non-broadcast, point to multipoint, And point to multi-point non-broadcast. There's three types. First three types. The timer is 30 and 120. Let us now go to more verification. You can see here the network type, a little higher. Okay, here. The network type is non-broadcast. Remember, I told you, if frame relay is encapsulation type, then it is considered as non-broadcast environment. In non-broadcast environment, the network type will be non-broadcast. Show interface serial 6/1. You can see the DLC numbers are involved. Local management identifier LMI type is there. Encapsulation is frame relay. So whenever you got frame relay, it is not going to be a broadcast network type. It will be non-broadcast. We learned it earlier. I'm just reminding. Fine. I'll go to R3. Interface loopback 0 IP address. IP OSPF for the area 0. Oh, right. Now, sorry, what I did. Sorry. What am I doing? Am I doing right? Yes, correct. Area 0. Show IP OSPF interface brief. You got OSPF. Show IP OSPF interface serial 6/0. The network type is non-broadcast. And the timer, you can see 30 and 120. Will the neighbor come up? No. This neighbor will never come up. Can I even say why the neighbor is not coming up? Who can say why the neighbor didn't come up? So we have configured OSPF and we got the tunnel ready already. I showed you the tunnel. OSPF is already pinging. See, you can ping 10.0.0.1. You can ping 10.0.0. 10.0.0.3 because I showed you the tunnel already frame later. When they're pinging, then why the OSPF is not forming neighbor? Who wants to give the answer, right answer? Why? Correct. Because it's a non-broadcast, no multicast is supported, and there's no multicast supported. OSPF is not ready to send any multicast traffic out. No hello packets. Hello packet uses what? Multicasting. So now we have to configure the neighbors manually. I'll use the notepad to do this because you're all BGP students, you know. Enable config team router OSPF 1 neighbor 10.0.0.3 neighbor 10.0.0.4 end right memory. This is what I'm going to put it on router 1. So I'm configuring neighbors manually. Show IP OSPF neighbor, no neighbors. Show IP route OSPF, no routes learned because you don't have neighbor. After I configure neighbor manually, the routes will be learned. Now let us do it. R1 is over. R3 is also over. See, you know why I use this notepad now? You know it. And R4. That's the beauty of using notepad, you know. Now our neighbors will come up. 1, 2, 3. Oh, very fast. The magic's happening very fast because the tunnel is ready. You see the neighbors come up now. Okay, let's go to route 1. Show IPOSPF neighbor. I can see that. Look at this. I told you there will be a DR-BDR election. That's why it is recommended for full mesh. Are we having full mesh? Of course we are having full mesh. And the one with the bigger outer ID is the DR. The second biggest is the BDR. Now, show IP route OSPF, you can see the routes. And if you ping, this ping happens. Ping happens. So you can ping the neighbors.
Question.
Yes, please.
So what is the OSPF network type now here?
It's the same default. I did not change any network type.
Non-broadcast.
Non-broadcast is the default. Yeah, only in. Yes. In non-broadcast, there will be a DR and there will be a BDR election. Neighbors should be neighbors should be manually configured. Timers are 30 and 120. All three routers here are in same subnet, right? 10.0.0.1, 10.0.0.0.3. All should be in same subnet. They cannot be in different subnet. What else? It is recommended for full mesh. Yes, these are the things that we saw. Did anyone write any notes on that day when I was teaching this? Anyone wrote anything in your notebook for this different type of NBMA?
Yes, I should have.
Okay, what we have written there under NBMA, can you please read those points?
No dynamic discovery.
Okay. Okay.
Should be a manual config.
Okay.
DR election.
That's all I want. That is the question as per our.
And recommendation mesh.
Yes, thank you. So there is a DR PDR election. Yes, please.
One more question.
One by one, please.
So, I'm trying to understand why is it safe to say that when the media types between all these routers are R4 is not something like serial or something else, it does not support broadcast. That is why this sort of a flavor of voice like an NBMA. That is why we have evolved.
Yeah, this 5 modes of NBMA is actually designed for an environment like this, as you are saying now, an environment that doesn't support NBMA. But today, we don't have such an environment. So why do we learn it? I told you, even though we don't have this type of environment, even on an Ethernet interface, you can go and change the network type to one of this if you want to have the OSPF adjacency policy that matches your policy. You see, under two routers that runs Ethernet, what will be the network type? Broadcast. Correct. Even on the Ethernet interface, you can go and say you are not a broadcast. You are non-broadcast.
So you can configure point to point, right? But again,
point to point is what most people will configure on the Ethernet interface. Even though it is not a point-to-point, they used to configure as point-to-point. Likewise, you also have an option called non-broadcast. And when you configure non-broadcast, you have to configure neighbor manually. If that is your expectation on the Ethernet environment, is your expectation? Is that your expectation that neighbors should not be dynamically discovered? Then go ahead on the Ethernet interface that runs OSPF and say this command. This is a command that you should say. Assume this as Ethernet. Okay, I can show it on Ethernet, but I don't have a wire here. But I can show you. Ethernet, fast Ethernet 0/1. I can say IP OSPF network type. I can say non-broadcast. I can say broadcast. I can say point-to-point. I can say point to multi-point. See, if I put this command, the neighbor discovery will not happen for you. Why it will not? See, it 100%. These commands are actually designed for serial interface. You will definitely have on serial interface, but I'm telling you, even on Ethernet interface, they are available. That is why we are learning it. Otherwise, we no need to learn this topic. These commands are even available now for you to configure under Ethernet interface. So you can have the benefit of all this you learned.
So in the middle, instead of the frame relay switch, you can actually
normal Ethernet switch.
And then you can configure the unit there as non-broadcast.
And then neighbors will be dynamic. Neighbors will be manually configured by you now. That's the only purpose of this topic. See, in production, mostly people will put this command on an Ethernet interface and make it as a point-to-point. You know why? They don't want DR-BDR election. But I'm telling you, you can also use this if you want the benefit of what we learned on the other day. You can also use this if you want the benefit of what we learned on the other day. Yes. Question, please.
Yes, sir.
Right.
I'm just looking for a question. Let's say my traffic flow is mesh all the locations we have from each other, and I'm going to get this non-broadcast disconnect in the default. So now, but my media, the carrier is MPLS. So can we go ahead with this connection?
Why not? Why not? There's no connection.
And if my RAM is broken, I can go with the point by default.
Yes. Yes, your wish. You can do that anywhere.
Irrespective of what
Transport. Irrespective of transport. Transport. That's the right word. Eh? Transport. Irrespective of transport. Transport may be MPLS. Transport may be LTE. Transport may be IP network. Lease line, whatever.
One more thing. So even in this particular setup, where you have clear interfaces, you can instead of configuring point to point, you can just configure those interfaces broadcast also.
Yes, this will start forming neighbor. You see, I'm going to show you that. I'm going to show you that magic now. I'm going to show you that. See, by default they don't form neighbor, right? They don't form neighbor, right? Now I'm going to make them form neighbor dynamically. I'm going to remove all the static neighborship. You see, R4, I think that configuration is R4. R3, R3. And this is for R1. That's not the way to do, sir. What will happen, on the interface and all, we enabled OSPF. You remember that also will get removed. Is that okay for you? No. You got it? Don't, why you want to completely remove OSPF? You want to you want to only remove this neighbor, right? Arindramji, are you there? No problem. You understand the problem?
Yes, yes.
Mhm. Clear IP, clear, clear IP OSPF process. Clear IP OSPF process. Clear. Okay, the neighbor is detached. This thing won't happen. There is okay. Clear IP. Okay, there won't be neighbor again. There won't be neighbor again unless you give neighbor manually, or we have to configure other network type. The neighbor will come up. What is this coming up? Just trying to come up. So something is still there, not removed. Show run section router OSPF. Nothing. Okay, it's gone actually. It was simply from buffer. Yeah, the neighbor is not going to come in here. Show IP OSPF neighbor. Will simply show it. Will never go to full state. It will be in two-way state only. Clear IP OSPF process. Good. Show IP route OSPF. Nothing will be there. Show I ping and say ping won't happen. Ping. Definitely don't ping. You know it because we don't have route now. You see, just by changing the network type, I can change the OSPF policy. I'm going to change the network type as broadcast, but it's not a broadcast. You see, interface serial 6/1 IP OSPF network type broadcast. That's all. This will start discovering neighbor dynamically. Interface serial 6/1 IP OSPF network type broadcast. Even though it's a non-broadcast environment, it will behave like. Now, after this, you will see neighbor coming up dynamically. And when you check under the interface, it will show network type as broadcast. Not only that, the timer. It was 30 and 120 earlier. Now it will be 10 and 40. Yes, it will be 10 and 40 because in broadcast it should be 10 and 40. Okay, but it's still frame relay only in the middle. Let's verify. Show IP OSPF neighbor. Okay, something is in extract state. Okay, full state. Router 4 has come to full state. I'm waiting for the other router also to come. It'll come soon. Because it's a frame rule, it will take some time to talk. The hello packets will not reach on time because unbelievably they have to go. It has to go through this tunnel. It is circuits. What /1? In which router? Show run interface serial 6/1. This is the line that I have typed. Now let's verify one more time. I'll go to router 3 and check the status. Show IP OSPF neighbor. Oh, no neighbor. Why? Show IP OSPF interface brief. OSPF is running. Okay. Clear IP OSPF process. Show IP OSPF interface brief. Show IP OSPF neighbor. If I sniff packets now with a Wireshark, I will not see anything because it's a frame relay. So I cannot troubleshoot also with Wireshark because it's frame relay. I didn't do that in router 3. Show one interface serial 6/0. Oh yeah, that's why. Thank you for interface serial 6/0 IP OSPF network type broadcast. That's the reason for the delay. See, immediately the OSPF has come up. Boom boom, two boom booms. Show IP OSPF neighbor. Show IP root OSPF, and I can ping now. Pop, pop, source. Pop, pop. Pings. Ping. Source. Dun. No, there's no source. That's why. Pings. Yeah. So now you know what is the purpose of those 5 different network types. Depending on your need, you can go and configure one of it on the interface. Now, what you will do if I want to configure the third type? Can someone say what is the third type that we learned? Very good. Point to multipoint on broadcast. If you see IPOSPF network type, you don't have point to multipoint non-broadcast. And how do you configure? It is very simple. First, you configure point to multipoint, and then put question mark. You will see that non-broadcast. Okay, that's it. All right, I'm not going to do it. Whenever you need it, you can do it. It may not be that much needed. Point to multipoint non-broadcast. Neighbors are not dynamically discovered in point to multipoint non-broadcast. And then there won't be DR, BDR also in that. All right. So if there is a situation, you can use it. Questions?
One last thing, can you do a show IPR on so the reason why I'm asking is
You will not see ARP. Inverse ARP. I said inverse ARP. See, it's going to use this DLC number and it will send the traffic via the tunnel and automatically it goes to the other end of the tunnel. Show ARP. You see, you don't see anything. Let me ping one more time for you. You will not see anything because it's not necessary. Because my job, if I want to go here using frame relay, I need to encapsulate to this address and deliver. It will go to this end of the tunnel. Tunnel is one pipe. Ah, that's a frame relay magic. Inverse is giving you this information. It's a frame relay magic. It's no more Ethernet standard, so no MAC address. All right. So frame relay is actually an interesting topic, but because it is not that much useful in production, uh, I did not spend them and waste your time. That's one thing. But I love to teach frame relay. Yeah. Uh, yeah. So, all right, fine. So we will OSPF stub areas. That is going to be our next topic. Tomorrow, okay, then I'll do one thing. Tomorrow I'll make it as CCIM